So, dear ladies and gentlemen, welcome to my presentation. My name is Filip Górski, and together with Mr. Damian Grajewski, we work at Faculty of Mechanical Engineering and Management of Poznań University of Technology. And the topic for today is immersive virtual reality in design. The main aims of the presentation are listed on the slide. First aim is presentation of a new hybrid prototyping concept that we have developed at our virtual reality laboratory. The second aim of the presentation is to present another concept of a design by the client for our system that we are developing with our industry partner. And the third aim is to show you main current projects that we are currently realizing at our laboratory in the scope of virtual reality. So the plan of the presentation, main part about the hybrid approach to product development, the second part about the design by the client system. It is a concept of an advanced vehicle configurator and immersive VR, and a short note about other VR projects at our laboratory. So a short introduction, just to remind everybody. We, together with Mr. Grajewski, we are part of a virtual reality CAD/CAM rapid prototyping group at Faculty of Mechanical Engineering of Poznań University of Technology. We work in a team of about 10 people, and we have 3 research laboratories: rapid prototyping laboratory, virtual reality laboratory, and reverse engineering laboratory. Our virtual reality laboratory here at PUT consists of 3 main workplaces. We have 2 haptic manipulators, both with large screen 3D active visualization, and we have separate room for immersive visualization with head-mounted device and various tracking systems for user head and hand tracking, and also gesture recognition gloves. We develop several types of virtual reality applications on a daily basis. As we are mechanical engineers, we deal mostly with devices, machines, workplaces. So the 2 main categories of apps are first object-oriented apps, where the object is at the main focus, and usually it's some kind of home appliance or machine or device or furniture piece or something like this. And subcategories of the apps that we develop are work and operation simulation and also instruction for user, simulation of assembly and disassembly, and also instruction for the process, and 3D product configurators, interactive configurators. We also developed the second type of applications are scene-oriented apps, which the whole environment is at the main focus, and we mostly do workplace simulators and also virtual tours. So virtual prototyping is our main activity in virtual reality field. For us, virtual prototyping is an extension to a traditional design process, and the traditional design process ends with a CAD model. So this is where the virtual prototyping starts. So every virtual prototype starts with a CAD model, which is transferred to a virtual environment and visualized there. And the most important part of each virtual prototype creation is programming of behavior of objects in response to user actions or in response to other objects or something like this. And after the object behavior programming is completed, the user interface must be created to allow intuitive and easy interaction with the virtual prototype. And after this, the virtual prototype can be submitted to tests that usually are aimed at verification of design. So we use lots of different software for this, and mostly CAD systems for the first stage, and also 3D modeling software for visualization techniques to make the visualizations more realistic. And our main VR environment that we use is EON Studio. And we also use various techniques to enhance our virtual prototypes. We frequently use user tracking and gesture recognition systems for more intuitive interface. And we often use haptic manipulation, haptic devices for tactile feedback, for force feedback. And we also use hybrid prototyping, which is the main concern of this presentation. It is a combination of virtual prototyping and rapid prototyping. So the main idea of hybrid prototyping. hybrid prototyping for us, it is a combination of a physical object, physical model, usually produced by rapid prototyping technologies, by additive manufacturing, and a virtual representation of this prototype put in a virtual environment. So physical object and a virtual scene together form a hybrid prototype. A hybrid prototyping is our contribution to JRA Action 5, enhancing 3D models, interactions, and visualizations with our devices. So the hybrid prototyping allows to combine the benefits of physical models, physical prototypes, and endless possibilities of virtual reality together. And user can manipulate with a real object, not by making gestures in the air, but just interacting with a real object, and the virtual scene, usually an immersive visualization, is put before his eyes. So it's making an experience more realistic. We have developed two main approaches to hybrid prototyping. The first approach is connected to haptic devices, and it is more for single objects like tools. And it's about complementing a haptic device with the real shape of used object as an end effector. So the user can manipulate with a haptic device, but with the real shape of a prototype object. And the second approach uses user tracking systems and immersive visualizations, and in this approach an immersive space with head-mounted device and user position tracking is complemented with real objects. We call them props, and these props are integrated with tracking system markers to make their representation be available in the virtual scene. So hybrid prototyping with haptics. It consists of few key stages. So the first stage is, like I said before, always a design. So the first stage ends with a CAD model of a tool, usually, that we will be using. And this CAD model must be adapted in order to fit to a haptic device. And after adaptation, the model must be 3D printed on a rapid prototyping device, on a 3D printer. After the model is ready, the physical model is ready, it must be assembled with the haptic manipulator, and then the virtual prototype is created as usual, with a huge accent put on the force feedback programming. The phenomena like weight of the object, like vibrations, and most of all the response of collision of the object must be programmed. And after the application is ready, it may be submitted to tests. The second approach, the hybrid prototyping tracking system, is based on the same idea as in the case of haptic approach. Of course, the CAD model is first, and it must be adjusted. Some kind of a slot or a place must be planned in the model to make it available to be integrated with the tracking system marker. If anybody can see my camera, it looks something like this. This is a tracking system marker, and it can be fitted inside an object manufactured using a rapid prototyping device. So on the slide you can see some examples of real objects linked together with tracking system markers. And of course, after the props are ready, the scene is created as by object behavior programming. And this time a huge accent must be put on the immersive visualization and gesture recognition. So, some examples. First example is a stud welding workplace. This is an example of the haptic approach, as you can see on the slide. And the object that had its physical model here was a stud welding gun. So we had a CAD model of the whole workplace, and we have created a stud welding gun in a form of a prop which can be mounted on the end effector of a haptic device. And the main idea was to verify the stud welding process, the ergonomic aspects of the stud welding process. So the force feedback was programmed, and the workplace was tested, was examined for ergonomic qualities. The second example of a drilling and assembly workplace. This is a double workplace, and this is also a student project. There are two workplaces in one application, two separate workplaces. The one workplace is for drilling of circular holes, and the second is for assembly of two halves of the pin coupling. And this is an example of the tracking approach to hybrid prototyping. The physical models here are models of tools used on the workplaces. It's tools like wrench or screw gun or something like this. You can see on the slide the manipulation on this workplace, and of course it is an immersive visualization, so the user has more free movement, can move around the workplace and manipulate with objects on it. And thanks to using real object shapes, the manipulation is more realistic. And of course, the gesture recognition is also present there. So the tests can be performed if the workplace is designed properly. Another example, third example, is a conceptual model of an industry manipulator, a new industrial manipulator, industrial robot. It was designed and the main idea was to test it in a virtual environment, and both haptic devices and tracking approach was used here. First, the virtual model of the industrial manipulator was connected to a haptic device, and workspace and collision zones were tested, and then the virtual manipulator was put in an immersive environment, and a real physical prototype of the control panel was created, as you can see on the picture on the slide, and various methods of controlling the robot were tested. So the gesture recognition was also implemented, and it was tested on the control panel how the robot can be controlled in real time. So a short summary about what we know right now about the hybrid prototyping. The two approaches both have their advantages and disadvantages, of course. The biggest weakness of the haptic approach is limited workspace and no free user movement, and of course that only a single object can be used at the time. And the biggest flaw of the tracking approach is that there is no force feedback there. The user manipulates with a real shape of object, but there is a ghost effect because there is no tactile feedback. But there are no limits in user movement. User can move freely around, and user can manipulate with many objects at once. So concluding, the haptic approach is better for ergonomic prototyping of single objects as tools, and tracking approach is better for ergonomic prototyping of whole environments like workplaces. The two approaches can of course be combined sequentially or even simultaneously to maximize the benefits of the whole concept of hybrid prototyping. And we need further studies a lot to determine if the hybrid prototyping can to some degree replace traditional design verification techniques. And we have also proposed an expansion of the tracking approach with a new haptic manipulator for real-time obstacle generation in an immersive environment. And this is a topic of JRA Action 13 realized here at PUT. So, to the second part about the design by the client system. This is another ongoing project that we are involved in currently in our laboratory, and this is a project with an industry partner. And our industry partner is a large Polish bus manufacturer, and this is something we called a virtual bus design center. And the main ideas are listed on the slide. It is a system for bus configuration, for selection of a configuration variant of the city bus, and it is designed to be with a client, so the client will interact with the system the whole time. There will be realistic stereoscopic visualizations present on each stage of the configuration. The interaction will be intuitive by gestures and natural movements and by graphical user interface. An immersive environment is also will be present in the system to allow accurate testing of the selected configuration variant. The system will consist of 3 subsystems, and they will be separate, but they will be connected. The data will be exchanged between them, and the data will be also exchanged between the system, the configuration system, and the CAD system to make it easier for design engineers to prepare the documentation for the variant. Main goal is to accelerate and facilitate the selection of the bus variant, because it's a very complex process. And second goal is to start avoiding mistakes related to client having poor imagination, not being able to see, for example, what color he selected, and so on. So immersive visualizations should help eliminate many mistakes made by client during selection of the configuration variant. And of course, integration with CAD systems and other PLM systems present in the company will be a nice benefit, making it easier to prepare the documentation of the selected variant. So the first subsystem of the virtual design center of the configurator is a preliminary configuration. We call it pre-configuration, and it will be based on a touch table on a device on a big touch screen, and it will be a basic. It will consist of basic features, so the user will be able to select main features of the bus, like size, like main colors, like seat arrangement, and it will be quick and intuitive. And the touch table can also recognize objects that are put on it. So putting a specific object on the table will induce a specific action. And data from this step will be transferred, of course, to the next step. And the next step is our main configuration stage. We will use a large screen 3D visualization here. And this is a main stage where user will be able to change whatever is possible to change in the bus, and he can do it alone or with the assistance of the operator from the company. And a complete bus model in the highest quality possible will be presented to the client, and he will be able to change anything is possible: colors, arrangements, element types, etc. And also interaction will be present, so actions like opening doors and other actions will be possible to perform. And navigation will be free, so the user could see exterior view of the bus and interior view of the bus in place that he wants. And the data will be, of course, transferred to the next step. The next step is an immersive visualization of the selected variant, and it will be based on tracking system and on head-mounted device. So the user in the second step he selects a advanced configuration variant, and in this step he can test it by walking around the bus that he just configured. So he will be able to see for his own eyes how the colors look, how the arrangements look, and how the bus looks from inside and from the outside. And of course, on this stage he still will be able to go back and to change the configuration options, and he will be able to do it here from the immersive environment, because we will give him a gesture-based interface. So he will also be able to change the configuration variant here. And the configuration process will end with report generation, and the reports will be sent to various divisions in the company in order to prepare documentation, and the client will also get his configuration, his visualization of his variant and data of his variant, and also a link to a CAD system will be provided to make it easier for the design engineers. The project has already started, as you can see on the dates down on the slide, on the bottom of the slide, and it is planned to implement the results of the project by the end of the year 2015 in the company. So other ongoing projects, we are currently involved in a collaboration with major Polish furniture manufacturer, and we do for them visualizations of their products, of interactive visualizations of the whole room arrangements, and also we do for them product configurators. And we have just recently started a collaboration with a medical university, and we will do for them our applications for anatomy and physiology lessons. So that is all I have to say. If there are any questions, the time is now. Thank you very much.